Question 3. Period 3 elements react with chlorine gas to form chloride. Okay, part A. This table shows that the reactions of the sodium chloride and the silicon tetrachloride with water. Okay, for sodium chloride, white solid disappear, colorless solution made. pH is 7. Okay, because it's just dissolved, no hydrolysis happen or no reactions happen. It just dissolution from the ion solution. The SiCl4 able to form bubbles and white precipitate. pH is 1 to 2. So part 1. Write an equations for the reactions occurring when SiCl4 added to cold water. Include state symbol. Okay, so one thing you must know is silicon tetrachloride is liquid. This one must be a liquid. Okay, reacts with water, liquid, form white precipitate SiO2, solid, and the bubbles means the white fumes, HCl gas, and after that you balance equation, so you get this. Name the type of reactions occurring when SiCl4 added to water. Okay, because the SiCl bond break is helped by water, so that's why we say that this reaction, this type of reaction is hydrolysis. Part 3. Explain in terms of bonding why NaCl and SiCl4 behave differently when added to water. So you have to specify the bonding. NaCl has ionic bonds which just dissolve in water to produce the sodium and the chloride solution, sodium ion and chloride solution. And the SiCl4 has covalent bonds which able to hydrolyze in water to form the white precipitate and HCl. So now their difference is what? One has ionic bond, another one has covalent bond. The one with ionic bond just undergo dissolution. The one with covalent bond undergo hydrolysis. Okay, part 4. Explain in terms of electronegativity why the bonding in NaCl different from SiCl4. Why NaCl is ionic, why SiCl4 is covalent? Because the electronegativity difference for NaCl is much greater than SiCl4. When the electronegativity difference is more, then it will be more polar until it can form ionic compound or ionic bonds. Okay, that's why you have to use this electronegativity difference between NaCl is greater than this SiCl4. Why is such a big difference? Because Na is less electronegative than silicon. Okay, therefore, the NaCl involves transfer of electrons between the elements. The sodium atom release electrons and the chlorine will get the electrons. So it involves transfer of electron to form this ionic compound or to form this ionic bond. SiCl4 is just covalent bond which just involves the shared pair of electrons. Part B. Chlorine dissolves in cold water and reacts with it. Not just dissolves, it reacts to form two different acids, HCl and HClO. Okay, part 1. Identify the oxidation number of chlorine in each of the species. Okay, Cl2 of course is oxidation number is 0. HCl, okay, hydrogen is positive 1, chlorine must be negative 1. HClO, oxygen is negative 2, hydrogen is positive 1, chlorine must be positive 1. Okay, part 2. Name the type of reactions occurring. Okay, because the chlorine is reduced and oxidized at the same time, so we just need to put the type, okay, as disproportionation. So disproportionation reactions happen. Okay, part 3. Explain why chlorine is used to purify water, means to kill bacteria. Okay, why it can use to kill bacteria? Because the chlorate ion, it will decompose to form chloride and the oxidizing agent. This oxidizing agent is the one that kills bacteria because it can oxidize the cell wall, right, and break it. Okay, so explain why chlorine used to purify water, because it's able to kill microbe. Okay, C. A mixture of HCl and HClO is added to NaOH. One of the products behave as a bridge. Okay, suggest the equations for this reaction. Okay, very easy. You can do it separately. HCl with NaOH, just a normal neutralization, form the salt and water. HClO and NaOH is similar, so now the salt is NaClO plus water. So you just combine all these reactants and products together, means left to left, right to right. So you get this equation. So you just put here. And which one is the bridge? This one, the sodium chloride. Okay, that's all for this question. Thank you.